Hey guys, so we came across this awesome little outdoor classroom which we are going to do our math project on. So we have this lovely board that says "See You Space Cowboy."
And we're just going to draw some triangles. It's still there, so we're just going to write over it.
Wait,
this is the planetarium. Okay. And right here is where our first point was.
AKA the bridges.
Yes. So basically this here is a pit. We don't want to go there. And this is our 90 feet away. So this area here is 90 feet. And we have our angle of depression, or angle of elevation.
Yeah, so if you look from right here, this going up is the angle of elevation.
Yes. And our angle of elevation from our second point up to the same spot. And this right here is obviously 90 degrees because it's 90 degrees. Our first angle when we were doing the measurements was it was 79.
Right.
Okay. So to find this angle here, you have to do 90 minus 79.
Because we used a clinometer, this is the way that you find out the
That's 8 and that's 10.
yeah, the ratio.
8, 18. So this angle here is 18 degrees. So this second angle here was 81 degrees.
Yes.
So to do that, you do 90 minus 81, which is 9. 9. So that's 9 degrees. So you have a 90 degree here, an 18. This is unknown as of right now. We're going to figure that out. And we have this one here. And like we said, X, we're trying to find that.
Which is the height of the planetarium.
Yes. And Maya is working on calculations.
Right. So basically, we did a drawing of our situation here. So this represents the
That's where
bridge
the
and
bridge.
pit. So our obstacle. This over here is a staircase. From the staircase to our obstacle, which is the bridge, we couldn't go over it because we have gyrophobia. That's 90 feet, which we calculated using our tape measure.
Yes. And you can see that to find the angle, you had to do 90 minus the 79, I believe is
and
what the angle was in the
81.
clinometer, and then the 81. So that's how you get these angles of elevation in the triangle here. This here is obviously going to be a 90 degree angle because that's where, that's what happens when you get a perpendicular object, and the planetarium, which is the one leg here, is our X, and that's what we're trying to find.
Yeah, so since we found that 90 feet exists between the staircase and the bridge, to get the base of the entire triangle from the staircase all the way over to the base of the planetarium, it's 90 feet, okay, which is what we calculated. Then we use 90 feet over here plus X because this space is unknown. So that's going to go into our substitution method that we're going to use right now. Over here, we're going to redraw it, but this is our, crude thinking calculation. Basically what we're going to do is multiply the tangent of 9, right there, by 90 plus X, which is right here. And tangent of 11, this angle of elevation, times 90, which is this. And this has to, this is due to substitution that we're able to do this. So we're gonna do that right now. So tangent.
Can I record this?
Yeah, tangent of 90. Oops.
Tangent of 11 times 90.
Times 90 equals 17.49.
So 0.5 because of rounding rules. 17.5.
Right. Okay. Oops. Now, since there's two different terms within this quantity, we have to multiply the tangent of 9 by each part of the quantity. So, first part is tangent of 9 times 90. Which is 14.2. Oh, I hate that sound. Then it's plus the tangent of 9 times x.
So you have to do the tangent of.
That's true.
So.
All right, that's 0.1. Well, 0.2, because we're gonna round.
Yep. So that equals that.
Yep.
I'll
Abby
take
can
it from
take
here.
over.
So, all right. Now we have these two, which are the same. So we're going to subtract 14.2 from both sides. And obviously we can't subtract the 0.2x because it has a variable and you can't subtract that. So these here are going to cancel out. And then you have to do 17.5 minus 14.2. So you'll get 3.3 equals 0.2x. So then you're going to have to divide by 0.2 to get x by itself. And because you're dividing by a decimal, you should get a big number. So x is 16.5. So now you have to take this number, because if you come over here, you're trying to find this x. So you have to do 16.5 plus 90. So this over here is 106.5 feet, which makes the total distance from the base of the planetarium to the stairs. Which
Wait,
is our
Abby.
farthest point.
Aren't we supposed to be finding the height of the planetarium?
Yes, I know, but I'm getting.
Okay.
So that makes the total distance 196.5. All right, so now we have a right triangle, okay, where we know that this angle is 90, this angle is 9, and we have 996.5 feet.
All right. So right now, we're doing the tangent of 9. So we're using this.
So now, yeah, we have our right triangle rules. Well, any triangle rules, SOHCAHTOA. So we're trying to find, using the big triangle, trying to find the opposite.
Which is the height of the planetarium.
Yes, opposite is the height of the planetarium, what we're trying to find, so that's x. So it's going to be tangent of 9 equals x over 196.5.
Which is what we just found in the previous segment.
Yes, so now to do that, because you can't do x over 196.5, you have to multiply both sides by 196.5. So that'll be 196.5 tangent 9 equals x. Would you like to take over?
Sure. And that will be the height of the planetarium.
Yes.
All right. Okay. All right, so first of all, tangent of x, decimal. Then we have to multiply that times 196.5, which is 31.
Hold on. Calculator error? So we're going to do 196.5 tan 9. 31.1. Which that planetarium is not 30 feet.
No.
So we're just going to ponder. Just going to think about this for a little bit and we'll get back to you.
So as we were kind of, going through the process of trying to find the height of the planetarium, what we thought about was that since we already did
Our substitution.
our substitution, we don't need to find like any other element of the triangle. This 196.5 is the height of the planetarium.
So when you do the 196.5 times the tangent of 9, Maya, can you just type that in quick? So it's 31.12.
Which obviously is not the height of the planetarium because
Like,
it's a big building.
Yeah, you saw the planetarium. It was in our video.
Yeah.
So what?
Just using common sense, like
Yes.
it's not 31 feet.
So now what I suggested is that we go back to the planetarium, take a look at it, and measure from the planetarium base to where we started measuring, which I know it's going to be difficult to conquer our fear, but I mean, for this project, I think we're going to try it.